Good afternoon. Derivatives of trig functions, and I got one set up, and we're only going to do one, and this will be quite enough, I would imagine. Here is the original cosine x over 1 plus sine of x, and we're going to take the derivative of it, and we're going to use the quotient rule. All right, so we're going to have to do, I'll put it right here, big old line there for the top and bottom. So we got low d high minus high d low. So it's low, and there's that, and then the derivative of the top. So the derivative of cosine of x is negative sine of x. Okay, and you all probably had that. And then minus, and I always suggest you put double parentheses there so that you remember to filter that negative sign through when you're done. So it's low d high minus high d low. I guess I didn't make that long enough. And the derivative of the bottom, 1 plus sine of x, would of course be 0 plus, I'll go ahead and write it, 0 plus sine of x. The derivative of sine of x is cosine of x. So then that gets a parenthesis, and we got to clean this up here. So, oh, and on the bottom, it's over low, low. So it's just 1 plus sine of x, quantity squared. And before I start foiling this, I'm just going to leave it. Okay, I'm going to leave it and see what happens here. Now, I'll make each step a new color. Okay, now I got to distribute this through here like that. So that's going to be negative sine of x times 1 is that. And then negative sine of x times sine of x would be negative sine squared x. All right. And then minus, and this would just be cosine squared here, because you got cosine, that 0 is just going to kind of go away. And cosine times cosine is just cosine squared of x, and since it was positive, I can just go ahead and remove the parentheses. You know, it started off like that, but in here it's positive, so I can just kind of ignore that and get rid of those parentheses and have it looking like that. The bottom, still not sure how I'm going to handle this yet, but I'm just going to, for now, leave it 1 plus sine of x squared, whole thing. All right, now I'm always looking for a few things. Okay, I'm always looking for stuff like sine over cosine, or when I start seeing stuff squared like this, I'm looking for this trig identity, sine squared of x plus cosine squared of x equals 1. Can I find that anywhere? Well, sort of, right? I have minus this, minus that. But what I could do is I could distribute, or I could factor rather, I could factor out negative 1 out of the top like this. Watch. Sine of x. Okay, so there's the bottom. And then on top, if I factor out a negative 1, I get sine of x, then what? Good. Plus sine squared x, then what? Plus cosine squared of x. And if you see this, the alarms need to start going off, because this right here, I'll circle it in white. Can't get any brighter than white. That right there is a giant number 1. Okay? So now, one more time. This right here, oops. This right here is a big number 1. That's that trig identity right there. All right, so now let's rewrite this. Negative 1 sine of x plus 1. Because this sine of x squared, sine squared of x plus cosine squared of x is just 1. And that's where this 1 right here came from. Okay, so that's a kind of a new concept there. Over 1 plus sine of x squared. Now, this top part in this parenthesis and this bottom part in this parenthesis are very similar. In fact, they're exactly the same. You know, because because of commutative rule, 3 plus 4 is the same as 4 plus 3, any order for that. So what I'm going to do now to clean that up a step is go like this. Watch. -1, 1 plus sine of x. So I flipped the order there. I did a switcheroo there on that. And got this. Over. Now I'm going to expand this out, but I'm not going to FOIL it. Okay, so it's going to be 1 plus sine of x times 1 plus sine of x. And normally I would start foiling it, but I think you can see what's going to happen here, right? That whole thing, this whole thing here, cancels one of these whole things. And so what I'm left with is -1 over 1 plus sine of x. And that's your final answer right there. All right, I hope you enjoyed that one, and you can see kind of how that works. Have a good one.